Section 4.3, Solving Systems of Linear Equations by Elimination. The elimination method for solving systems of equations is based upon the following property of equality. If A equals B and C equals D, then you can add A and C together, and that will equal B plus D. So A plus C equals B plus D. You can add two equations together at the left sides, at the right sides, and you get another equation that should be equal also. So what we're going to do is write both equations in the general form, ax plus by equals c. Then we're going to choose the variable that we want to eliminate. Usually one variable will be easier to eliminate than the other, and we'll talk about that as we look at the example problems. We may have to multiply one or even both equations by an appropriate number so that the coefficients of the variable to be eliminated are opposites. Boy, that sounds complicated, but it's not. We'll see how to do that. You add the equations together, and when you add them together, one of the variables is eliminated. Then you solve for that remaining variable. You substitute the value you get into either of the first equations, and then you check your answer. So let's do some example problems. Solve by elimination. So in this problem, we have 3x minus 2y equals 4 and 4x plus 2y equals 10. Notice that the y variable in the first equation is minus, the coefficient is minus 2. In the second equation, it's positive 2. Those are opposites. When the coefficients of a variable in two different equations are opposites, then if you add the equations together, minus 2 plus 2, those will cancel each other out. So the y's will be eliminated. That's your whole goal, to eliminate one of the variables. We have eliminated y if we add these two equations together. 3x plus 4x is 7x. 4 plus 10, 14. So that gives us an equation that has just one variable in it because we eliminated the y's. Now we can solve for x. How do we get rid of 7? It's 7 times x. We divide. So x equals 2. Now that we know what x is, it is 2, you can choose either one of the original two equations and substitute 2 into the equation in place of x. 3 times 2 minus 2y equals 4. 6 minus 2y equals 4. Let's subtract 6 from both sides. Minus 2y equals minus 2. Divide by negative 2. Y equals 1. And if y equals 1 and x equals 2, that's our solution. As an ordered pair, we could say the point 2, 1 is the solution. It's where these two lines cross. This must be a situation where the two lines cross at one single point, and that point is the point 2, 1. We can check that point, make sure it's a solution, by substituting it into our second equation, 4x plus 2y equals 10. Let's check it. So is 4 times 2 plus 2 times 1, does that equal 10? Well, that's 8 plus 2. Does that equal 10? Yes, it checks. Let's go to the next example. 3x plus 4y equals 4, and 6x equals 6y plus 1. All right, I like the first equation, 3x plus 4y equals 4, but I have a problem with the second one. What's my problem with that second equation? Is it in general form? No. We need to get it in general form. The 6x is fine, but we need to remove the 6y from the right-hand side. We'll subtract 6y from both sides. And now our second equation is in general form. We need both equations to be in general form. So now we're trying to figure out which variable do we want to eliminate, x or y. Would you rather work with a 3 and a 6 or a 4 and a negative 6? I personally would rather work with the 3 and the 6. I need to work with that equation, or work with one equation or perhaps both equations until the numerical coefficient of x, until they are opposites. I have a positive 6 in the second equation. Is there anything I can do to the first equation so that it will have a negative 6? Well, if I could multiply the second equation by a negative 2, that would give me a negative 6. Can you just decide to multiply both sides of an equation by a number? Sure you can. So if we multiply by negative 2, we'll get negative 6x, negative 8y, negative 8. Make sure you multiply everything in the first equation by a negative 2. So now, if we were to add the second equation with our new version of the first equation together, look what happens to the x's. They're opposites, so they are eliminated. 6x minus 6x is 0, so the x's are eliminated. We now have minus 14y equals minus 7. Let's divide both sides by minus 14. And we get y equals 1/2. Y is 1/2. All right, if y is 1/2, what's x? You can go to either one of the original two equations. It doesn't matter, just pick one. I'm going to pick the first one, so if we have 3x plus 4y equals 4, and we know now that y is 1/2, so let's substitute 1/2 into that equation. Then we have an equation with just one variable in it. And when we have that equation, we can solve for x. Subtract 2 from both sides, divide both sides by 3, and we get x equals 2/3. So putting it as an ordered pair, we have 2/3, 1/2. What a disgusting answer. It's fractions. But there's lots of fractions in life, so maybe we shouldn't think they're so disgusting after all, because fractions happen. So substituting that value into the second equation, we will find out if it checks. 6 times 2/3, does that equal 6 times 1/2 plus 1? 6 times 2/3 is 4. Does that equal 3 plus 1? Yes, it does. It checks. So we substitute our values into the other equation that we haven't used yet, and we check our answer. Here's another example. 2x plus 3y equals 1, 5x minus 2y equals 12. Do we want to get rid of the x's or the y's? It is up to you. I am going to choose to get rid of the y's. That's just what I want to do when I look at it. I think that 3 and 2 are smaller numbers. I like the fact that 3 is positive and 2 is negative, so it seems like a good way to go. Honestly, it doesn't matter. You can get rid of the x's. You will get the same answer. So let's just go with the y's for the time being. So we have plus 3y and minus 2y. We want them to have the same coefficients, except we want them to be opposites. So thinking about 3 and 2 and thinking about what's the least common multiple of 3 and 2 is a lot like finding a common denominator. The least common multiple is what we need, and it's the same kind of thought process that happens when you're looking for a common denominator. We want the smallest number that 3 and 2 will divide into evenly, and that number is 6. So we are going to have to fix both equations so that one has a positive 6y and the other has a negative 6y. That means that we need to multiply the first equation by what? What will give us a positive 6y if we multiply by 2? So then we'll have 4x plus 6y equals 2. So that's good. We have this second equation. We want the second equation to have a negative 6y. We currently have negative 2y. What do we need to multiply by? A 3. So that gives us 15x minus 6y equals 36. So now when we add these two equations together, since we have plus 6y minus 6y, since they are opposites, they cancel each other out. We have 19x equals 38. We need to solve for x. X equals 2. When x equals 2, what is y? I don't know. We have to use one of the first two equations. It doesn't matter. 2x plus 3y equals 1. Use one of those original equations. Let x be 2. And solve for y. Subtract 4 from both sides. Divide by 3. And you get y equals negative 1. So our solution then is 2, negative 1. That must be the point where these lines cross. We can check our answer by substituting those values into the equation that we didn't use to find x. So 5x minus 2y equals 12. Let's take 5 times 2 minus 2 times a negative 1. Does that equal 12? Does 10 plus 2 equal 12? Yes, it does. So that answer checks. Two x plus 3y equals 1, and 4x plus 6y equals 2. Let's solve this equation. We need to eliminate either the x or the y. It doesn't matter which one we decide to eliminate. Remember, we want the coefficients to be opposites. So let's say that we decide to get rid of x. And we have a positive 4. We wish that the other one were negative 4. Well, what can we multiply that first equation by so that we can make it have a coefficient, x have a coefficient of negative 4? If we multiply it by negative 2, that'll do it. So we'll get negative 4x minus 6y equals negative 2. What happens when we add these two equations together now? X's are eliminated, but look, the y's are eliminated too. We get 0 equals 0. Everything's eliminated. Even the 2 and the negative 2 are eliminated. 0 equals 0. That's something that's always true. And what did we say when we were doing substitution? If something is always true, that tells us that these equations represent the same line. So if they represent the same line, then when you graph them, one line is on top of the other one, right? It's the same line, and that's the situation where we said there are infinitely many solutions, because every point on the line represents a solution to our equation. One more to solve. 3y equals negative 3x. That's not in general form. And 2.5x minus 5 equals 15. We need to have it in general form, so we're going to take our first equation. Remember, general form is where the x and the y are on the left, and if you have a number, it's on the right. So we're going to add 3x to both sides on that first equation, and that will give us 3x plus 3y equals 0. We need to be able to add these equations together so that either the x or the y is eliminated. I would like to eliminate the y because it's a plus 5 or a minus 5 and a plus 3. Those numbers don't have a fraction. So, I don't know, I just like it. So let's see if we can figure out what to do to these equations. What's the least common multiple of 5 and 3? What's the smallest number they divide into evenly? The answer is 15. So we want one of these equations to have minus 15y and the other equation to have plus 15y. What are we going to have to multiply the first equation by? 3. The second one? 5. So we have to multiply both equations by something so that we will end up with a plus 15 and a minus 15. So multiplying the first equation by 3 gives us 7.5x minus 15y, that's what we wanted, equals 45. The second equation, we get 15x plus 15y, good, equals 0. So now when we add the equations together, what's eliminated? Y is eliminated. So that gives us 22.5x equals 45. We have to divide both sides by 22.5. And that gives us x equals 2. When x is 2, what is y? Well, look at our original two equations. Pick one. I'm going to choose 3y equals negative 3x. Substitute x equals 2 into that equation. That'll give us negative 3 times 2. So 3y equals negative 6. Solve for y. Y equals negative 2. So our solution is the point 2, negative 2. And we can check that point by substituting it into that other equation, 2.5x minus 5y equals 15. Let's substitute our values into that and see if it holds true. So 2.5 times 2 minus 5 times a negative 2, does that equal 15? 2.5 times 2 is 5. Minus 5 times minus 2 is plus 10. Does that equal 15? Yes, that does. It checks. That is a solution. That's all for this section.